Temperature and pressure conversions are up next. So what we're going to talk about first is temperature conversions, and in order to understand the converting that you need to do, there's two scales that we need to explain. So the first one you guys are all very familiar with, it's the Celsius scale. We know that the freezing point of water is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. And so the way the scale is kind of set up right now is that we stick 100 ticks in between that, and each tick then represents 1 degree Celsius. Now, obviously, 100 degrees Celsius is not the ceiling for that scale. Things can get a lot hotter than that, and so that scale can continue up as hot as we can get things to go. This, though, over here on the basement side of things, on this scale, there is a temperature where we can remove all of the heat out of a particular object. And when we remove all the heat out of that object, that just means that that object's molecules, those particles that are in that substance, no longer are moving. And once we're at 0 heat, you can't get any colder than that. And so there is a basement for this, and that temperature is minus 273 degrees Celsius. The other scale that we need to understand is what's called the Kelvin scale. And the Kelvin scale is much like the Celsius scale in that 1 degree Celsius increase on this scale is going to be 1 increase in the Kelvin scale as well. But the 0 has been set at something different. So what they decided here for the Kelvin scale is, let's set the 0 at not the freezing point of water, but let's set it at where a substance has 0 heat. And so down here at this part of the scale is where they call it 0 Kelvin. Notice that it's not 0 degrees Kelvin, it's just 0 Kelvin. And that is equal to minus 273 degrees Celsius. Now, remember, as I just mentioned, that if I increase by 1 degree on the Celsius scale, that's going to correspond to 1 increase on the Kelvin scale as well. And so you can obviously see that as I go up the scale in equal increments, that the freezing point of water on the Kelvin scale is going to be 273 Kelvin. And the boiling point of water is going to be 373 Kelvin. So in order to convert between the two scales, which you're going to need to do throughout the course of this unit, is if I'm going from Celsius to Kelvin, I'm going to add 273 to that number. And if I'm going from Kelvin to Celsius, then I'm just going to subtract minus 273. And that will allow me to do my conversion. So if you take your calculator here for a second and you go 75 degrees Celsius, what is that temperature in Kelvin? So you just go 75 plus 273, and that gives you your number of 348 Kelvin. And if you have 75 Kelvin, obviously that number is going to be way down here. It's going to be some negative number in the Celsius scale. 75 minus 273 is going to give me a negative 198 degrees Celsius. And so that's how you convert between the two temperature scales. There's a couple of practice questions in your practice booklet. You can attempt those. Moving over here to pressure conversions. There's a variety of pressure units that you need to know for this unit. There's 3. The first one is what's referred to as millimeters of mercury. And this came from an old device called a barometer that was designed to measure air pressure. And so at sea level, these barometers they were designed and they would show that there was 760 millimeters of mercury that would go up the little tube at sea level. And so they just naturally said, okay, if there's 760 millimeters of mercury that go up this little capillary tube, then let's just set that as the air pressure at sea level. And so they said at sea level, we had 760 millimeters of mercury. So then somebody else decided to come along and say, well, let's come up with a new unit for pressure, and let's just say that at sea level, we have a full Earth's atmosphere sitting on top of us. And so let's just simplify this a little bit, and let's just say that's 1 atmosphere. And so at sea level, again, they said, all right, here's this new unit of pressure. We'll call it 1 atmosphere, and that's at sea level. And then finally, the unit of pressure that we're actually using the most nowadays is what's called kilopascals, and so they've converted this into a number for that scale as well. And so I'm just going to give you the number. This is the number in kilopascals of the pressure at sea level. And it's 101.325 kilopascals. Now, all these numbers and these conversions here are all found in your data booklet, so it's not something that you have to have memorized for any assessments or anything like that. They're all there given to you. But what you need to know how to do now is to be able to convert from atmospheres, say, into kilopascals, or, for example, kilopascals into millimeters of mercury. So I'll show you again, using unit analysis that we've reviewed and talked about over the course of the semester already, how to solve for these problems and what the unit analysis should look like as you're showing your work in your workbooks. So we start with question number 1. We have 2.00 atmospheres, and we know from this conversion factor up here that 1 atmosphere is equal to 101.325 kilopascals. So in your mind, you're thinking, okay, this is pretty easy. This is a pretty simple problem to do. But again, showing this using unit analysis is important so that you can connect it to something that you already know. So when we dive into this next one, hopefully it makes sense. So I want to make sure that I'm sticking what I'm looking for on the top, 101.325 kilopascals. And what I'm not looking for, or what I want to cancel out, on the bottom. And this is the conversion factor. I know that for every atmosphere that I have, I'm going to have 101.325 kilopascals. And so if I do the math this way, where I have the atmospheres on the bottom and the top, then that's going to cancel that unit out. And then I just go 2 times 101.325 kilopascals, and that gives me an answer of 203 kilopascals. Remember that when you do your rounding, you have to round your answers to significant digits. And because this number here is 3 sig digs, my answer here must also be in 3 significant digits. For question number 2, I've got 97.6 kilopascals, and I need to convert that into millimeters of mercury. So 97.6 kilopascals. And I know that, again, here's my millimeters of mercury, and here's my kilopascals. So I know that I want millimeters of mercury, so I stick that on the top, and the kilopascals goes on the bottom. So then you can see the kilopascals will cancel out. Plug that into your calculator, and you end up with 732 millimeters of mercury. Again, rounded to 3 significant digits because that's the number that was provided to me in the question. It had 3 sig digs. And so hopefully this gets you on your way as you start to do some of those practice questions out of your booklet. Hope you guys are doing well. See you in the next video.